Multi-party computation, or MPC. This video will present you the basics of MPC. What is MPC? For simplicity, let us view MPC as a black box. This black box computes a function. We provide the function with input x. Then output y is generated. Let us explain this using an easy example. Assume 4 colleagues. They agree that whoever has the highest salary pays the bill. However, none wish to disclose their salary due to privacy concerns. They agree to use MPC, submit their input data, and learn that Bobby has the highest salary without learning the salary of each individual. The information is kept private during this process. How does MPC work? MPC makes use of cryptographic protocols to preserve privacy and confidentiality. Typically, these protocols make use of secret sharing. Let us continue using the 4 colleagues which do not wish to share information about their salary. Now, they want to know their average salary, since they all have the same occupation. If they were to provide their salary information, average salary is calculated by summing up the values, then dividing the summed value by the amount of people. The 4 colleagues learned that their average salary is 6,100. The problem is, however, that these colleagues do not wish to share information about their salary. Then instead of using raw data, we repeat the process using a form of secret sharing. Let us view the salaries as parts. The parts are split into shares. 4 shares in this example. We provide each share with a random number. For each stack of shares, the values sum up to the real value of the salary. These shares are distributed randomly between the colleagues. Each person then holds 4 random shares. And they all get new totals. It is clear that the information each person holds is meaningless to them. Now these colleagues, together, can combine their totals, and learn that the total is 24,400, resulting in the same average. A practical use case example in an organizational context. Assume several companies. They wish to enhance their marketing efforts. They agree to use MPC, contribute their data, and new knowledge is created without disclosure of the underlying data. Through an intersection function, for instance. In sum, MPC is a protocol that enables knowledge creation through a function, while not disclosing the underlying data. A description of actual schemes and protocols is beyond the purpose of this video. For the viewer who is interested, Shamia's secret sharing provides a good starting point. How is MPC deployed in practice? In general, MPC comprises input parties, computing parties, and result parties. Input parties contribute protected data such as confidential or private data. The independent computing parties jointly compute a function according to the MPC protocol. The result parties receive results of the computation. These may or may not be the same as the input parties. The process starts with the input parties contributing their data. Their data is split in shares. 4 in this example. Each share is encrypted with a different encryption key. These shares are sent to the computing parties. Note that the encrypted shares are also distributed in random order. As a result, none of the computing parties know which shares they hold. Then the computing process starts. All computing parties jointly compute the function according to the MPC protocol. The result is jointly computed, then distributed, encrypted, to the result parties. In conclusion, with MPC the data contributed by the participating parties is kept private during the data contribution process. All parties only learn from the output. MPC applications are effective for specific problems, that is, specific functions.